In this video, we're going to look at the gate valve. The gate valve is quite interesting because it's one of the most common types of valve and it's also one of the simplest. So let's take a cross section so we can actually have a look at the insides of the valve. So here we have a gate valve. I'll push the play button and then we can watch the gate valve operating or actuating. So now it's in the closed position and it's moving up to the open position. You can see that when the valve is fully open, there is very little resistance to flow passing through the valve. Now this is very good because this means we're going to have a very low pressure drop. So as the fluid or the gas is flowing through the valve, it's going to encounter very little resistance and we'll have a correspondingly low pressure drop. Now gate valves are normally used in line. That means they're used just to pass flow through, but occasionally you might need to close the valve and isolate the system, and that is what a gate valve is for. Gate valves are only used for open and close. They're not used for throttling or regulating the flow. I'll show you why. If we look down here at the bottom of the valve, you can see it's fully closed now. The disc is pressed against the seat. I'll pause it. Now it is only half open. So this is in the throttled position. The problem with this is that firstly, the amount of flow through the valve is not proportional to the amount that this gate has travelled. So the disc, this section here, has travelled up and it looks like approximately halfway. But the flow through the valve is not going to be half of the max flow capacity. The flow through the valve is not linear or proportional to the amount the valve is open. This means that when you actually open the valve halfway, you're going to get a lot of flow between the disc and the body here, and this is going to be proportionally quite a large amount of flow with a high velocity. This high velocity often leads to seat and disc wear. The other problem, apart from the high velocity, is the turbulence. As the flow passes through this small gap between the disc and the body, there is a lot of turbulence, and this also creates a larger pressure drop, which again is what you don't want. This is resistance to flow. So gate valves are not very well suited to throttling. In fact, they should either be only fully open or fully closed. While we're down here, we can have a quick look at the seat. The seat, this area around here, is normally either part of the body, such as a flat machined surface, or we'll use seat rings. And seat rings are usually metal rings. The advantage with these seat rings is that if the seat becomes worn, you can just change the seat ring. So seat rings make it easier to repair a valve, such as by repairing the seat if it's leaking, by simply swapping the rings out. In order for the valve to seat correctly, we need both the disc and the seat to be machined flat so that they can press against each other and form a seal. So we already know that we can potentially use seat rings and we can replace the seat rings if the seat surface becomes damaged, but that still leaves the disc. The disc is going to be one of two designs. It's either going to be inclined or parallel. There are three different designs for inclined discs. These are actually referred to as solid wedge, split wedge and flexible wedge. And then we have the parallel disc, which is not an inclined disc. So there are three designs that are inclined and one design which is actually parallel, which is two flat surfaces. We're going to talk about all of those disc designs later on in the course, as well as the seat designs. If we move up, we can actually see the stem. The stem passes all the way through the valve bonnet and through the sealing arrangement and up through the handle wheel. This is interesting because if we watch, we can actually see the stem rising out the top of the hand wheel and dropping back down again. So it's going to keep rising up and dropping back down. This type of design is what we refer to as a rising stem gate valve. It makes it really easy to see the position that the valve is in because the stem's just going to pop out of the top. In order to achieve this, what we've actually done is fix the stem, pause that a moment, fix the stem to the disc. So the stem is connected to the disc. It is not going to move inside the disc or anything like that. It's totally fixed And that means that as we rotate the hand wheel, the stem is going to be pulled upwards and it's going to pull the disc up. This is a slightly different design to what they call a non-rising stem gate valve. There are two main designs, rising stem and non-rising stem. As I said earlier, it's easy to see if the valve is open or closed. The downside is that sometimes you will carry bits of dirt on the stem here, and when you close the valve, like now, the dirt, etc., will pass through the packing or potentially damage the packing, which will damage the seal, and maybe then you will get a leak. So contamination is a potential problem with rising stem gate valves, but the big benefit is that you can actually see visually if the valve is fully open or fully closed. If we just take a look now at a non-rising type of gate valve. This is a non-rising type gate valve. I'll explode it out and I can show you the parts. See, we've got the hand wheel, the bonnet, a small gasket for sealing, the stem, and we can see the stem, in comparison to the other design that we looked at, has a thread going all the way down. The reason that we have this thread going all the way down is because as we open the valve, the thread is going to screw into the disc, into this section here. It's going to go all the way through the disc. As it screws into the disc is going to be pulled up the stem. As it's pulled up the stem, we're going to open the valve. So rather than having a rising stem, we're going to have a non-rising stem, because this is just going to turn, and as it turns, the disc will move from here, the bottom part of the stem, and it's going to be dragged upwards, obviously, until it reaches the bottom of the disc. Typical service temperatures are going to be between about -20 to 60 degrees Celsius. Pressures up to approximately 16 bar. These valves are not suitable for very high pressures because you're actually going to blow the packing out or cause the packing to leak. So 16 bar would be the max service pressure. And for flow rates, you're looking at anything between 5 to 20 meters per second, depending upon if the flow medium is a liquid or a gas. For liquids, the flow rate is actually going to be less, so you're looking in the 5 meters max per second range. And for gases, you're looking up to maybe 20 meters per second. We're going to look at all of these aspects of the gate valve later in the course, and we're going to go into a lot more detail. So let's now go to the next lesson, and we can have a look at the next valve design.